Hey, welcome back to RamZland. Today I want to share with you the polarization of corn syrup. Check this out. All I'm using in this investigation is polarized film that I've cut out in circles, some cardboard that I cut out in circular rings for my polarized film, my hot glue gun to glue it all together, some corn syrup, this Christmas tree glass to put the corn syrup in, and some hot glue, and my scissors. Start by making your first circular polarized lens by gluing it to the cardboard ring that you cut out, and then glue the second ring to the outside of it to keep your polarized lens nice and flat. So your first lens, if you glue it together, should look something like this. So it's nice and flat. Okay, now make your second lens the same way. So once you've made both your lenses, it's time to test them. When I look through both lenses, I can see the chair behind them. But when I start to rotate my second lens, those even intervals that are like picket fences that allow light to oscillate through them, if I keep rotating that second lens, pretty soon I can't see the chair behind them. And that's because that second polarized lens is no longer lined up with the first lens, and light can't pass through it. So if I rotate a little bit more, now I can see the chair. If I keep turning it, I no longer can see through it. So now we're ready to test what will happen when we pass light through these two lenses and through corn syrup. Let's find out what will happen. Okay, so in honor of Christmas, I thought to use a Christmas tree glass, and I'm gonna fill it with my corn syrup. Careful not to spill any corn syrup because it's tough to clean up. In order to demonstrate how different wavelengths of colored light pass through different gradients within the polarized lens, I'm gonna put this light behind the first filter, and then I'm gonna have my corn syrup, and then I'm gonna rotate the second filter in front of it while the light is shining. And as I rotate it, you'll see different colors will break through different gradients within the second polarized lens because each color of light has a different wavelength. Check this out. Okay, I'm gonna turn on my light. And here's my second lens. Watch what happens when I start to rotate it. The corn syrup turns blue. Now watch. It's red. Now it's orange. I'm gonna keep rotating it. It's gonna turn green. Look at that. Now it looks blue again. There's purple. And as I rotate this second lens, I'm changing the gradient of the polarized lens so only a certain wavelength of light can oscillate through the lens. There's orange, it moves to yellow, here comes green. Isn't that amazing? Here comes blue. That is awesome. Kind of that red, kind of that magenta, orange. Just amazing. The other thing to remember in this demonstration is that corn syrup has sugar in it that's optically active, and as light refracts through the sugar, it creates different colors of light. I hope you enjoyed today's edition of RamZland, and I'll see you next time.